AI on the edge requires platforms that are going to be powerful, but very low power nature. Um, so, Sam, could you tell us a little bit about what a sparse processing unit is?
Yeah, absolutely. Thanks for having me on. So our company is Femtosense, and we make AI accelerators and platforms for everyday devices. Our specific accelerator is called the Sparse Processing Unit. It is a kind of neural processing unit, or NPU, you might have heard in the world. And the name really sort of tells you how it's different from a normal NPU. When you're doing AI, what a lot of people have observed, but at least in our experience, nobody has really exploited, is that the AI workloads they can be highly redundant, and you can remove a lot of them, right? You can zero out a lot of components of it. Like, you don't have to use everything that you could possibly do here. And what we do is our AI accelerator, our NPU, has custom instructions, custom memory formats, and a full stack of software and also applications to really exploit that, right? So if you can take an AI algorithm and deploy it in, say, 1/10 the silicon, 1/100th the power, well, that means that it can go in a lot more places, right? So that's the, I guess, the story has up until very recently been that you need to make very large sort of AI models, and you need to spend a lot of money to introduce them into your products and deliver these features to customers. But I think as recent events have shown, there's a lot of room for innovation in the algorithm side. And what we're contributing to the mix is that, especially when you unlock more algorithm innovations, namely the sparsity techniques, really down all the way to the hardware level, you can really do something that allows AI to go everywhere.
What kind of models can you support? Is this something where you have to design something specifically, or you can take existing models that you may have been targeting for other AI platforms?
Yeah, that's a great question. At the end of the day, our AI accelerator is really a linear algebra accelerator, and happens to have some custom sparsity magic with it. So yes, absolutely, we do support other AI algorithms. There's nothing inherently, uh, in opposition between sparsity and AI algorithms. Our first product, the SQ001, is targeted more towards the audio and voice space, but our upcoming products will be sort of flexible and able to handle everything from, of course, the audio and speech, in addition to vision and some language, larger language capabilities as well. But the idea of sparsity is that, yes, if you have an AI model, if it fits, it should run, right? And then what you can do is, well, you can say, well, now I have this resource. I could deploy something that's like 5, 10 times bigger. So I'm going to use that and make something that's even more performant, more flexible, have a better feature set. There's a lot of room for growth here.
Now, the chip itself is actually extremely small. It has an SPI interface. Uh, can you tell us a little bit more about it? And how much power does this thing require?
Typical use cases, any from like 100 microwatts to a few milliwatts is the range of applications. So this really depends on what you're doing. If you're doing something that's sort of listening all the time for certain events in the world, certain phrases to be said, that's closer to the hundreds of microwatts range. If you're doing something that's really real time in the loop, you got to do millions of operations per second in real time, then you're looking at some single digit milliwatts range there. So it really depends on the task. In terms of the size of the thing, the chip has 1 MB of SRAM that typically dominates the space of the accelerator. So basically, if your model can fit in there with the sparsity bonus, then you can deploy it. So yeah, it's about 3.4 scale millimeters. It's tiny enough to fit inside of, let's say, the smallest hearable devices out in the world, things that fit maybe entirely in your ear. They can't see from outside. But of course, it doesn't have to go in things that small. We also are very active in, say, like the home appliance space, where, of course, the devices are much bigger. There, the concern is not so much power, though power is, that phantom current is definitely a concern for them. It's really more about sort of the, integration capabilities and the cost, especially.
Now, this is designed to essentially work with a host processor, but you have a version that integrates a Cortex M0 Plus. Tell us about that and what are the application spaces for it?
Yeah, absolutely. So the SVU itself is really a coprocessor, right? It's that NPU component of a system, right? And so it will always be paired with, some kind of processor, whether it's M0, some people are doing RISC-V, we're agnostic to that. What we've done with one of our partners, Above Semiconductor, they are a Korean microcontroller company, is that we put this all into one package. So this is called the 001. It looks like one chip on the outside, but really it's a couple different silicon dies inside. And this allows you, have a number of advantages. One, you can actually get to market fairly quickly. You're able to mix and match process technologies. So we're fairly advanced in terms of MCU land. 22 for the SDU1. They're at a much bigger process node. But it allows you to have this sort of all-in-one kind of AI MCU is what we're calling it, solution, so that you deliver the cutting edge AI capabilities along with the sort of known quantity of the MCU as well.
So if you want to get started with this, what kind of development kits do you have?
Yeah, so we make a couple of different evaluation kits available. The one that we do most commonly is called our EVK2. Is based on actually the Timpan open source hearing aid platform, which is our T2Dino platform. But this is an all-in-one sort of hearable development platform. So if you want to, well, one is portable, which is very important. And then it has the microphone interfaces, has audio output, various kinds of microphone interfaces and output. So it's everything that you might want to build a, say, hearable product on top of this SP001.